Okay, so here we are solving a system using the elimination method. So elimination method essentially means they have to be lined up with your variables right on top of each other and your constants on the other side. This one is not set up in the right preference, so we're going to have to rearrange that one, but we'll worry about that one in a minute. Now the goal here is to use a multiplier to multiply your whole equation to essentially get one of your variables cancel out. Is it possible that you'll have to use a multiplier to both of your equations? Of course, and this is a good example of that phenomenon. So what catches my eye is that the x's already have it kind of set up where this is a positive and this is a negative. However, they're not opposite. So what I'm going to do is I'm going to take a multiplier and multiply that by 3. That's going to give me 6x. So if I multiply this one by a 2, that's going to give me a negative 6x. But don't forget, whatever you multiply your left-hand side by, you have to multiply by your right-hand side. So what does that look like? Once we multiply it, we're going to get 6x minus 9y equals 33. And we're going to get negative 6x plus 10y equals negative 34. Then we add it. So sometimes the elimination method is also called the addition method. 6x minus 6x, those get canceled out. Negative 9y plus 10y gives me y. 33 minus 34 gives me negative 1. Again, remember, I need an ordered pair, and right now all I have is the negative 1 part. So I have to take this and back sub it into either one of my equations. I'm going to choose to substitute it back into my first equation. Again, this is a preference. So 2x minus 3y equals 11. Now the y is going to be replaced with the negative 1. 2x minus 3 times negative 1 equals 11. 2x plus 3 equals 11. Move the 3 over to the other side, which gives me 2x. We're going to take away the 3 from both sides. That would give me 8. Divide both sides by 2, and I get x equals 4. So my ordered pair, or my answer, is 4, negative 1. This one, B, is a little bit more complicated because notice the variables are not on the same side. You have them on opposite sides, and so here we're going to have to be intentional about rearranging. So I'm going to have 6x minus 4y equals 12. I'm going to move, oh look, this is already kind of set up on the left-hand side. You're just going to have to restructure it, but the signs don't change. So negative 5x plus 3y equals negative 6. Again, notice that nothing's going to directly cancel out, so I am going to have to do a multiplier on both of them. Kind of a pain, but that's okay. So notice that these are already set up for the opposite, and so are these. So I guess if we use a multiplier on to cancel out my y's, it'll at least give me a little bit smaller number. So I'm going to be focused on the y's. So I'm going to multiply that by a 3 and that by a 4. So equation 1 now becomes 18x minus 12y equals 36. This one would become negative 20x plus 12y equals negative 24. I'm going to add those together. My y's cancel out. That gives me negative 2x equals 12, or x equals negative 6. Now what do I do with this? I back sub it into either one of my equations. Doesn't really matter. I'm going to choose to just put it back into the first equation. What's the first equation again? 6x equals 4y plus 12. Now it's going to read 6 times negative 6 equals 4y plus 12. Negative 36 equals 4y plus 12. Move my 12 over to the other side, which would give me negative 48 equals 4y. Divide both sides by 4. And I get negative 12. And so now my ordered pair is negative 6, negative 12, and that is my solution. These are both linear, so it really just means these are both consistent systems. They both meet, and when they meet at an actual ordered pair. Now, something I haven't mentioned before, but all systems that are linear, you can use your matrix to solve it. So you could put these in your matrix and do RREF. And so what would that look like? 2, negative 3, 11, negative 3, 5, negative 17, and then do RREF, and you would get 1, 0, 4, 0, 1, negative. Negative 1. And so you can get your answer there to check it. Now, the only backlash of that is if we specifically say use the elimination method on the test, we do expect this method to be displayed. But this is a good, nice safety net to check your work to make sure you did the elimination correctly. Hope this helps.